Alright, Nolan. Let's look at this new function. We need to find g prime of 2 for the function g of x, which is defined as the integral from 2 to x of 3t over the square root of t squared plus 5 with respect to t. Rather than trying to evaluate this integral from scratch, what core concept can we apply here?
Since we are taking the derivative of an integral from a constant to x, we can just use the first fundamental theorem of calculus.
Spot on. And from a first principles perspective, remember that the derivative essentially undoes the accumulation of that integral. So what happens when we apply the theorem to find g prime of x?
We just drop the integral and substitute the upper bound x in place of the variable t. So g prime of x equals 3x over the square root of x squared plus 5.
Exactly, you've got the general derivative function. Now, the problem asks us to evaluate this at x equals 2.
Plugging in 2, the numerator becomes 6. The denominator becomes the square root of 4 plus 5, which is the square root of 9. So we get 6 over 3. Which simplifies perfectly to 2.
Take it home. Excellent work. You correctly identified the theorem, applied the substitution rule, and executed the algebra flawlessly.